This is a kind of an extension or a project that I started doing last year um, with my stats kids after chapter 9 because it goes right along with what we've been talking about. But what I've done here is I've actually taken data from Blue Hill students, and these are last year's senior class. If I had you guys as data from Mr. Hubble, I would probably plop those in here. And we would do that instead. But these are going to be last year's senior class. I have 12 students here. There was only 12 students that had scores before John Baylor and then scores after John Baylor. So this was the date that they took the test before doing the John Baylor test prep, and then this was the date that they all took the ACT on the same day. Okay, and so we're going to kind of look at those test results and kind of see going by these categories. So the composite score would be all 4 categories together. And then just looking at math, science, English, reading, did it improve or did it, did John Baylor not really affect the scores at all? Was it kind of a waste of time? So listed below the ACT test results of 12 students at Blue Hill. Student names are taken out, obviously. The left table shows the results the most current test before taking the John Baylor test. So if they took it, there was a couple students that had taken it 3 times before they had taken the ACT altogether, and so I took their most recent one. The right table shows the scores immediately following the John Baylor test prep when they did it all together. So what I'm going to do is I am going to, this should say compute, not computer, compute the differences between the 2 tables. Okay, so what we're going to be doing here is looking at means, so the mean or the average, and since these are matched pairs, basically student 1 has data here and student 1 has data here. So those are matched up against each other. This is going to kind of follow from section 9.3, I think it was, 9.3. So I have my notes out for 9.3 so that we can eventually use this formula. And so what I want to do first, and you're going to eventually do this for all of the columns here, but I'm going to just do the composite. We're going to do the bottom part here, and then I'll save the back side of this sheet for the next video. Okay, so we're just going to do the composite first. And what I want to do is I want to look at these composite scores. So for student number 1, they went from 14 to a 15 composite score, which means that I'm going to do the second one and subtract the first one. So 15 minus 14 means that they improved their score 1 point. Okay, so that's the differences when we subtract them. How much did they go up or how much did they go down? So this person had a 26 before they had a 25, so they also went up 1. Here there was a 28 and a 28, so they did not increase at all. We went from a 25 to a 26, so that's increased by 1. 15 to 19, that was a jump of 4. Okay, from 22 to 24, that was a jump of 2. 19 to 20, jump of 1. 29 to 32, that's an increase of 3 points. 24 to 24, that's 0. 22 to 22, none of these people have gone down yet. I'm really surprised. 22 to 22 was 0 point increase. 25 to 27 was a 2 point increase, and 17 to 19 was another 2 point increase. Holy cow, I can't believe nobody went down. So here's the deal. This is what we're trying to test. Basically, given these composite scores, okay, was this a large enough increase overall to say that John Baylor did have an effect on these kids? Okay, or those, maybe if each one of these was 1s, they're probably going to say, well, that might have just been a fluke. But we'll see if this shows a large enough increase in order to say that John Baylor was effective. Okay, so composite scores. Use the differences above to test the claim. Here's our claim. The claim that the average composite scores before test prep is the same as the average composite scores after the test prep. Okay, so we're saying that the averages, which is represented as mu, are going to be equal to each other. We're saying the average before the test is the same as the average after the test. Okay, so that's what we're claiming. Okay, and we're going to test to see if that's true. That's going to go with the null hypothesis. So mu1 is equal to mu2. And then mu1 is not equal to mu2. Okay. All right, and what we're going to do is we need to figure out what our test statistic is. So that's going to be here in just a minute. But I went ahead And we're going to test this using every significance level. Normally, they just give us like 0.05 or 0.1 or something like that. We're going to test it on every significance level to see if this makes a difference, okay? And it's not going to really be that much more work. I'll just kind of show you how that works here in just a second. But since we have equal to, we're going to have two tails. Okay, so we'll have a tail here, and we'll have a tail here, okay? And so for the 20%, that means that we have 10% in the one tail and 10% in the other tail, right? Okay, for 10%, this means I have 5% here and 5% here. This one would be 5%, so that means I have 2.5%, 2.5% into, already it was 2.5%, how about that, 2.5%, okay? And this 0.01 is 1%, so that's going to be 0.5% here and 0.5% here, okay? So really, this 10%, 10%, this is going to be an 80% confidence interval. 90% confidence interval is the middle. This is 95, and this isn't 99%. So when we look up on our table, we can see what those critical numbers are, okay? So before we do our test statistic, let's look up those numbers in the table so we just have all of those, okay? So I want to use, you have to decide whether we want Z or T. So the Z or T table. We have 12 students, okay? Which means that that's less than 30, which means I'm going to have to use the T table, okay? So the T table I have here. And since there's 12 students, I'm going to use 11 degrees of freedom. So 11 degrees of freedom right here. And then let's just go ahead and write each one of these numbers down. So first I want an 80%, okay? So 11 degrees of freedom, 80% is going to be 1.363 is how I'm going to write this, and negative 1.363, okay? That's where these markings are going to be at, those cutoff marks. And then I'm just going to figure out where our test statistic, when we calculate that, where he lives in between there, okay? So 90% is the one right next to that, so this would be negative 1.796 and positive 1.796. Okay, 95% right next to that, negative 2.201 and positive 2.201. And then the last one is 99%, so we skipped over the 98%, which is this column. And 99% at 11 degrees of freedom is 3.106 and negative 3.106. Okay. All right, so we're going to refer to those here in just a minute when we figure out what our test statistic is. Okay. So to do the test statistic, I'm going to look back at section 9.3, which is that matched pairs. Okay. And the formula that we need is, let me see if I can get this all on one screen right here. This one right here. Okay. So this formula, I'm going to copy him down over here. T is equal to, I need to find out what D bar is, minus mu D, okay, which we always plug in as 0 because the difference is, if we're saying they're equal, that means the difference is 0, okay. Standard deviation is this guy, and the square root of n is that guy. Okay, so we're going to figure out what our test statistic is. So I need to know what D bar is, which is the average of the differences, okay. So using these numbers up here in this column, I need to find the average of those, okay. This guy's standard deviation. So I need to find the standard deviation of these guys. And then the square root of n is going to be 12. I'm going to plop 12 in there because there's 12 students, okay. So let's go ahead and do this. I have the square root of 12 on the bottom here, and I need to figure out what those two numbers are. Okay, so I'm going to go over to, I'll put this right next to here. I'm going to go over to my spreadsheet, and I'll kind of do this one for you. 1, 1, 0, 1, 4, 2, 1, 3, 0, 0, 2, 2. Okay, mean, I need average. The average of those numbers is, I'll put down over here, D bar equals 1.42, let's say. Okay, standard deviation, I'll put 1.42. 1.42 here. Okay, standard deviation equals STDEV. Okay, SD is 1.24. I'll put 1.24 here as well. Okay, so I'll put those in two different spots so I can see them. All right, so D bar, 1.42 minus 0, so I really don't need that 0 in there, and 1.24, and then I need to calculate my test statistic. Okay, so 1.42 divided by, I'm going to do parentheses, square root, no, not square root first, 1.24 divided by the square root of 12. Okay, here we go. Okay, so my test statistic is 3.97, 3.97-ish. Okay, so just judging by this test statistic, we have to figure out where he lives. Okay, so 3.97 is going to live, okay, he's living on the right-hand side over here, okay? So 3.97 is going to live, if I look at all of these numbers, it's going to live in the black area for every single one of those numbers, regardless of which one I have here, okay, because 3.97 is on that right side, okay, which means that I'm going to reject, okay? Okay, sorry, I had to go put my computer up on the charger, so if it looks different, my paper looks different, then that's why. So we had reject as our solution here, because each one of those stars is going to live in the black, which means we are rejecting the fact that the averages are equal to each other. So we are saying that the averages are not equal to each other, okay? And because he lives over here, this would mean that mu2 would have to be larger than mu1. So we're saying that the average composite score the second time was greater than the average composite score the first time, okay? Which each one of them was, but we were trying to test to see, okay, was it significantly larger? Because we could have it be just a hair larger, and that really doesn't make a difference. It's kind of like, well, if you had only 10 purple Skittles and you should have had 12, is that gonna really make that much of a difference? Well, not really, right? But they are saying that this is significant enough to say that the second time scores are larger than the first time scores, regardless of what we say our significance level is. So we're going to reject the null hypothesis. Does John Baylor test prep appear to have an impact on ACT composite scores? Yes. Let's see, composite scores for after John Baylor were higher at every significance level. Okay, so this is saying that based off of this data, we have all of the data is saying that John Baylor was a good thing, or John Baylor did help improve scores. Okay, so what I want you to do, just to get us ready to go for the next video, is I want you to fill in these 4 columns, okay, so that we kind of have that ready to go. We'll do math on the back side here, and then I'll have you do something by yourself. But fill these in, so go ahead and subtract these and figure out, like 16 minus 15 would be 1, and then keep going on down and fill each one of these 4 columns in, and do that for tomorrow. You don't need to send that to me yet, because we'll finish the back side of this and then I'll have you send this in. But get those 4 columns ready to go for tomorrow.